May 26, 1940. The skies above Dunkirk churned with smoke and metal as squadron leader Geoffrey Stevenson banked his Spitfire through a deadly ballet of aerial combat. Below him, thousands of Allied soldiers crowded the beaches, desperate for evacuation, while German dive bombers screamed down like mechanical vultures. Stevenson had just sent a Junkers Ju-87 Stuka spinning into the channel when tracer rounds tore through his cockpit. His radiator was hit. Coolant streamed behind him like blood from a wounded bird. With his Rolls-Royce Merlin engine overheating rapidly, Stevenson had minutes before complete failure. He pointed the nose of Spitfire N3200 toward the French coast and prepared for what he hoped would be a survivable crash landing. The aircraft hit the sand at Sangate Beach, doing over 90 miles per hour. Metal screamed against stone and sand as the fighter carved a violent furrow before coming to rest mere yards from the surf. Stevenson crawled from the wreckage, battered but alive, and began his long journey toward Belgian resistance fighters who might help him escape. Behind him, his Spitfire sat broken on the sand, its distinctive elliptical wings twisted, its proud RAF roundels already being photographed by German soldiers as trophies. What neither Stevenson nor anyone else could have predicted was that this aircraft would vanish beneath French sand for nearly half a century, only to emerge decades later as the centerpiece of one of the most extraordinary restoration projects in aviation history. A project that would transform a corroded pile of metal into a flying legend through the obsessive dedication of a motorcycle racer and lorry mechanic who refused to accept that some things were beyond saving. The mathematics of impossibility were about to be rewritten, not in engineering textbooks, but in the oil-stained hands of craftsmen who understood that the difference between scrap metal and a soaring Spitfire was nothing more than time, skill, and an absolute refusal to give up. This is the story of how one man's mechanical genius and stubborn determination brought a national treasure back from the dead. A story that proves the most remarkable victories often come not through force or technology, but through the quiet persistence of those who see possibility where others see only wreckage. The path to that beach at Sangate had begun months earlier in the workshops of Supermarine Aviation Works, where skilled craftsmen had assembled N3200 from thousands of individual components. Built in Southampton during 1939, this Mark 1A Spitfire represented the cutting edge of British fighter design. Its elliptical wings, conceived by designer Reginald Mitchell and refined by aerodynamicist Beverly Shenstone, provided unmatched maneuverability. The sunken rivets that studded its aluminum skin had been carefully hammered by hand to create the smoothest possible airflow. Every component had been precision-fitted according to blueprints that specified tolerances measured in thousandths of an inch. By April 1940, N3200 wore the markings of 19 Squadron at RAF Duxford. The unit had been among the first to receive the new fighter type, and their pilots were still learning the aircraft's capabilities. Unlike the sturdy Hurricane with its fabric-covered wings and conventional construction, the Spitfire demanded finesse. Its narrow undercarriage required careful handling during landing. The hand-operated hydraulic system for raising and lowering the gear took 36 pumps of a lever to cycle completely. The two-position propeller had to be manually adjusted from fine pitch for takeoff to coarse pitch for cruise flight. Pilots learned that the aircraft rewarded precision and punished carelessness in equal measure. Squadron leader Stevenson understood these nuances better than most. Before the war, he had been a member of the Royal Air Force aerobatic team, threading his aircraft through aerial maneuvers that demanded split-second timing and absolute trust in his machine. His logbook recorded hundreds of hours in various fighter types, but the Spitfire impressed him immediately. Its responsiveness bordered on telepathic. A slight pressure on the stick produced instant reaction. The aircraft seemed to anticipate his intentions, rolling and climbing with an eagerness that made other fighters feel sluggish by comparison. On that morning of May 26th, as Stevenson strapped himself into N3200's narrow cockpit, he could not have imagined he was beginning the aircraft's first and final operational sortie. The mission was routine by wartime standards: patrol the Dunkirk area, provide air cover for the evacuation, engage enemy aircraft when encountered, return to base with fuel reserves intact. Simple instructions that masked the deadly complexity of aerial combat over a battlefield where German and Allied forces struggled for control of every mile of sky. The engagement that doomed N3200 lasted perhaps 90 seconds. Stevenson spotted the Stuka diving toward Allied positions and positioned himself for an attack from the bomber's blind spot. His 8 Browning machine guns, each loaded with 350 rounds of ammunition, converged their fire at a point 250 yards ahead of his aircraft. The Stuka, caught in that lethal cone of bullets, rolled over and plunged into the sea. But German fighter cover arrived before Stevenson could escape. Erich Rudorfer, flying a Messerschmitt Bf-109, had already claimed 4 aerial victories. Stevenson would become his 5th. The German pilot's cannon shells punched through N3200's cooling system with surgical precision. Glycol coolant, the Merlin engine's lifeblood, sprayed across the cockpit windscreen in sticky streams. Engine temperature gauges climbed rapidly into the red zone. Without coolant circulation, the 12-cylinder engine would seize within minutes, transforming 130 horsepower into twisted metal. Stevenson had trained for this scenario, but training and reality proved vastly different experiences. The aircraft shuddered as the engine began its death throes. Control surfaces grew heavy as hydraulic pressure bled away. The channel stretched endlessly below, its cold waters promising certain death for any pilot forced to ditch. The beach at Sangate appeared through the haze like salvation itself. Stevenson lowered his landing gear manually, cranking the hand pump with desperate efficiency. He had perhaps 30 seconds before complete engine failure. The aircraft touched sand, doing nearly twice normal landing speed. Metal shrieked against stone. The port wing crumpled first, spinning the fighter sideways before the starboard wing collapsed in turn. When the wreckage finally stopped moving, N3200 sat mortally wounded but recognizably intact. Stevenson unbuckled his harness and climbed from the cockpit, leaving behind an aircraft that would soon disappear beneath shifting sand. German soldiers arrived within hours. They photographed the crashed Spitfire from every angle, posing beside the RAF roundels like tourists at a monument. Some removed small components as souvenirs. The propeller blades were particularly popular, their polished metal providing excellent trophies. Over the following weeks, curious Wehrmacht personnel continued visiting the crash site. They marveled at the aircraft's construction, noting details that intelligence reports had failed to capture: the thin wing sections, the complex undercarriage mechanism, the sophisticated gun sight mounted above the instrument panel. But the tide waited for no aircraft, and Sangati Beach experienced dramatic changes with each lunar cycle. Spring storms pushed sand and debris across the wreckage. Summer calms allowed sediment to settle in the aircraft's cavities. Autumn gales redistributed the accumulated material. Winter freezes locked everything in place until spring thaws began the cycle anew. Month by month, year by year, N3200 sank deeper into the French coast. By 1942, only the tip of the vertical stabilizer remained visible. By 1943, even that had vanished completely. The war continued without N3200. Other Spitfires took its place in 19 Squadron. Newer marks with improved engines and expanded fuel capacity entered service. The basic design proved so successful that production continued throughout the conflict, with over 20,000 examples eventually built. Fighter sweeps over occupied Europe became routine operations. The desperate defensive battles of 1940 gave way to offensive campaigns that carried RAF fighters deep into German territory. Victory seemed increasingly certain, but thousands of aircrew paid the ultimate price to achieve it. Squadron leader Stevenson spent those years as a prisoner of war, eventually finding himself behind the walls of Colditz Castle. He filled notebook after notebook with observations about aircraft design and combat tactics, planning modifications he hoped to implement. When the war ended, He wrote detailed analyses of the Spitfire's strengths and weaknesses, based on his limited but intense experience with the type. His forced landing at Sangate had given him unique insights into the aircraft's crash characteristics. The strong cockpit structure had undoubtedly saved his life. The fuel tanks had not exploded despite the violent impact. The control system had remained functional until the final moments. Meanwhile, beneath French sand, N3200 underwent its own transformation. Salt water penetrated every crevice, beginning an electrochemical process that would continue for decades. Aluminum components developed white powdery corrosion. Steel parts turned to rust-colored flakes. Fabric control surfaces rotted away completely. The leather seat cushion became a shapeless mass. Rubber components hardened into brittle fragments that crumbled at the slightest touch. Yet the basic structure endured. The main wing spars, forged from high-grade aluminum alloy, retained their essential integrity. The engine block, cast from iron and protected by its own mass, survived relatively intact. The transformation was invisible but relentless. Each tide brought fresh salt water into contact with metal surfaces. Each storm shifted sand that acted like liquid sandpaper against exposed components. Each season's temperature changes expanded and contracted materials at different rates, creating stress fractures that propagated slowly through the structure. By any reasonable engineering analysis, N3200 was being systematically destroyed by forces no aircraft was designed to withstand. But destruction and preservation operated by different timescales in the unique environment beneath Sangate Beach. The sand that ground away surface details also protected underlying structures from oxygen exposure. The salt water that corroded some components created protective patinas on others. The constant burial prevented the thermal cycling that destroys aircraft left exposed to weather. N3200 was simultaneously being destroyed and preserved, its fate balanced on environmental factors that no engineer had ever calculated. 46 years passed. The Battle of Britain became history. The pilots who had flown Spitfires in combat grew old and died. The aircraft factories that had produced thousands of fighters were converted to civilian purposes or demolished entirely. Aviation museums around the world displayed carefully restored examples of Mitchell's masterpiece, but these were typically late-war variants with bubble canopies and powerful engines. The early marks that had fought over Dunkirk and defended Britain became increasingly rare. Collectors and historians began searching for any surviving examples of the fighters that had faced the Luftwaffe during those desperate months of 1940. In 1986, an unusually severe storm struck the French coast. Waves carved new channels through Sangate Beach. Currents shifted sand deposits that had remained stable for decades. When the weather cleared, beachcombers discovered metal fragments scattered across the tide line. Closer investigation revealed aircraft components, the distinctive shape of a Spitfire wingtip protruding from a sand dune, the curve of a propeller blade gleaming in morning sunlight. After nearly half a century of burial, N3200 was announcing its presence to the world above. The excavation team that arrived at Sangate Beach in the spring of 1986 expected to find scattered debris, perhaps a few recognizable components suitable for museum display. What they discovered defied every assumption about aircraft preservation in marine environments. As bulldozers carefully removed tons of sand, a complete fighter emerged from its sandy tomb. The fuselage remained intact from nose to tail. Both wings, though twisted by the original crash, retained their elliptical shape. The cockpit canopy had long since disappeared, but the instrument panel sat frozen in time, its gauges and switches arranged exactly as Stevenson had left them during his desperate escape. Pierre Clostermann, the legendary French fighter ace, who had flown Spitfires with the Royal Air Force, visited the excavation site during those crucial weeks. His assessment was blunt and devastating. The aircraft was beyond restoration. Corrosion had penetrated too deeply into critical structures. The engine was a solid mass of rust and sand. Control cables had disintegrated into metallic powder. Even the most optimistic evaluation suggested that perhaps 10% of the original components might be salvaged for display purposes. The rest belonged in a scrapyard, not a museum. Yet something about the aircraft's condition intrigued the recovery team. Despite 4 decades of saltwater exposure, the main structural elements showed surprising integrity. The wing spars, though heavily corroded, had not failed completely. The fuselage frames retained their basic geometry. Most remarkably, the engined Stephenson's mount still held Rolls-Royce Merlin in perfect alignment with the propeller shaft. This was not the random pile of debris they had expected to find. This was a complete aircraft that had simply been waiting for someone with sufficient vision to recognize its potential. The wreckage was transported to the underground V3 Museum at La Forteresse de Mimoyec, where Hitler had once planned to launch his V3 superweapon against Allied targets. For more than a decade, N3200 sat in climate-controlled storage, while aviation historians debated its significance. Some argued that the aircraft represented an irreplaceable link to the Battle of France, one of only 4 surviving Mark 1A Spitfires from that crucial period. Others maintained that restoration would be impossible and prohibitively expensive, requiring the fabrication of thousands of new components to replace those destroyed by corrosion. The debate continued through the 1990s as restoration technology advanced and wealthy collectors began paying extraordinary prices for authentic World War II fighters. Computer-aided design allowed engineers to recreate complex components from fragmentary remains. Specialized metallurgy could reproduce alloys that matched original specifications exactly. Advanced welding techniques could join dissimilar metals without compromising structural integrity. What had seemed impossible in 1986 gradually became merely difficult and expensive. In 2000, American billionaire Dr. Thomas Kaplan and British aviation enthusiast Simon Marsh made a decision that would transform N3200's fate forever. They purchased the corroded remains and commissioned Historic Flying Limited to undertake what many experts considered the most ambitious Spitfire restoration ever attempted. The project would require recreating an entire aircraft from little more than a structural blueprint and a pile of corroded components. Success would produce one of the world's most historically significant fighters. Failure would consume millions of pounds while destroying irreplaceable artifacts. Historic Flying's workshops at Duxford Airfield had earned a reputation for impossibly complex restorations. Their craftsmen worked with hand tools and techniques that had changed little since the 1940s, when Supermarines factories produced hundreds of Spitfires monthly. Sheet metal was formed over wooden blocks carved to match original contours. Rivets were installed by hand, each one carefully aligned and properly tensioned. Welding was performed by artisans who understood that wartime specifications demanded perfection, not merely adequacy. The restoration team faced immediate challenges that would have defeated less experienced workshops. Original blueprints existed, but they specified materials and manufacturing techniques that were no longer available. Modern aluminum alloys possessed different properties than wartime equivalents. Contemporary rivets used slightly different dimensions. Even paint formulations had evolved, making it impossible to achieve authentic surface finishes using modern materials. Every component required extensive research to determine not just what it should look like, but how it should be manufactured. John Romaine, Historic Flying's managing director, had served his apprenticeship at Hawker Siddeley and understood Spitfire construction from first-hand experience with the original manufacturers. His assessment of N3200's condition was more optimistic than earlier evaluations, but still sobering. Perhaps 20% of the original structure could be preserved and incorporated into the restored aircraft. The remaining 80% would need to be fabricated from scratch, using N3200's remains as patterns to ensure dimensional accuracy. The engine presented particularly complex challenges. Stephenson's original Merlin III had been reduced to a solid block of rust and sand. its internal components fused into an indistinguishable mass. The 12 cylinders that had once produced over 1,000 horsepower were now little more than metallic sediment. Yet within that corroded hulk lay precise dimensional information that could guide the creation of a replacement engine. X-ray photography revealed the positions of critical components. Careful excavation exposed bearing surfaces and mounting points. Pattern makers could use these discoveries to recreate parts that matched original specifications exactly. RetroTrack and Air UK received the contract to rebuild N3200's power plant. Their workshop specialised in wartime engines, maintaining the skills and equipment necessary to manufacture components that commercial suppliers had abandoned decades earlier. Cylinder heads were cast using sand moulds created from original patterns. Pistons were machined on lathes that predated computer numerical control. Crankshafts were forged and balanced by craftsmen who had learned their trade during the war years when such engines powered the aircraft defending Britain. As the restoration progressed through 2001 and 2002, historic flying's workshops became a magnet for aviation enthusiasts and documentary filmmakers. The process of recreating a complete Spitfire from corroded fragments fascinated observers who had never witnessed such ambitious reconstruction work. Television producers recognized the dramatic potential of following the project from initial assessment through first flight. The story combined historical significance, technical complexity, and human determination in ways that appealed to audiences far beyond aviation circles. Channel 4 commissioned a full-length documentary about the restoration, but the production team needed a presenter who could bridge the gap between technical expertise and popular appeal. The requirements were demanding. The presenter needed genuine mechanical knowledge to understand the restoration process. He needed sufficient charisma to engage viewers who might know nothing about aircraft. Most importantly, he needed the credibility to work alongside craftsmen who had devoted their careers to preserving aviation heritage. Guy Martin seemed an unlikely choice for such a role. The Grimsby lorry mechanic and motorcycle racer had built his reputation on two wheels, not wings. His television appearances had focused on mechanical challenges related to trucks and motorcycles. He possessed no formal qualifications in aircraft restoration or aviation history, yet his genuine enthusiasm for mechanical engineering and his hands-on approach to problem-solving impressed the production team. More importantly, the craftsmen at Historic Flying welcomed him as a kindred spirit who understood that the difference between success and failure often lay in attention to seemingly insignificant details. Martin's involvement transformed the restoration from a purely technical exercise into something approaching mechanical archaeology. Each component told stories about wartime, manufacturing techniques, design compromises, and operational requirements. The hand-pumped undercarriage system revealed the priority placed on simplicity and reliability over pilot convenience. The fabric-covered control surfaces demonstrated the continuing use of traditional materials even in cutting-edge designs. The 8-gun installation showed how designers had maximized firepower within severe weight and space constraints. The restoration workshops at Duxford became Martin's classroom in mechanical precision. Unlike the racing motorcycles he knew intimately, the Spitfire demanded tolerances that pushed 1940s manufacturing to its absolute limits. Each rivet hole had to be drilled to exact specifications using hand-operated equipment that predated modern power tools. Sheet metal panels were formed over wooden blocks carved by craftsmen who had learned their trade during the original production runs. The process was painstakingly slow, methodical, and utterly unforgiving of shortcuts. Martin discovered that restoring N3200 meant learning to think like a wartime engineer working under impossible constraints. Aluminum was scarce during the Battle of Britain, so designers had minimized material usage through elegant structural solutions that modern engineers struggled to comprehend. The elliptical wing that gave the Spitfire its distinctive silhouette was not merely aesthetic. Its shape provided maximum structural strength with minimum weight, but manufacturing those compound curves required skills that few craftsmen still possessed. The wing spar restoration alone consumed 6 months of intensive work. Each spar consisted of multiple aluminum sections, joined by precisely positioned bolts and reinforcement plates. Wartime manufacturing had used dies and jigs that no longer existed, forcing the restoration team to recreate these tools from scratch. Martin watched master craftsmen measure, cut, and form each component by hand, checking dimensions against blueprints that specified tolerances in thousandths of an inch. A single miscalculation could compromise the entire wing structure. As winter settled over Cambridgeshire in 2002, the restoration reached its most critical phase. The corroded fuselage frames that formed N3200's backbone required complete reconstruction. These components carried flight loads from the wings to the tail, distributed engine forces throughout the airframe, and provided mounting points for every major system. Original specifications called for aluminum alloy sections that were no longer commercially available. Modern equivalents possessed different strength characteristics and thermal expansion rates that could cause failures decades in the future. The solution required sourcing period correct materials from aviation scrapyards across Europe. Restoration teams had learned that aluminum manufactured during the 1940s contained trace elements that gave it unique properties. These materials had been developed specifically for wartime aircraft production, using techniques and additives that peacetime manufacturers had abandoned for more economical alternatives. Finding sufficient quantities of authentic alloy became a treasure hunt that extended across 3 countries. Martin threw himself into every aspect of the work with an intensity that impressed even veteran restoration specialists. He learned to operate forming presses that shaped aluminum panels into complex curves. He mastered riveting techniques that required perfect coordination between hammer strikes and backing support. Most challenging of all, he learned to read the subtle signs that indicated when a component was approaching its stress limits. Aluminum gave few warnings before catastrophic failure, demanding constant vigilance from anyone working with the material. The engine restoration progressed simultaneously in workshops 50 miles away. RetroTrack and Airs specialists had completely disassembled the corroded Merlin, cataloguing every component before beginning the painstaking process of determining what could be salvaged. The crankshaft, despite 4 decades of saltwater exposure, retained sufficient dimensional accuracy to serve as a pattern for manufacturing a replacement. Cylinder heads were beyond recovery, but their remains provided crucial information about combustion chamber geometry and valve timing. Building a Merlin engine from scratch meant mastering manufacturing techniques that commercial industry had forgotten. Each cylinder head required over 40 hours of machining on equipment that operated with mechanical precision rather than computer control. Valve seats were hand-lapped to achieve gas-tight seals. Piston rings were fitted individually, with clearances measured in fractions of thousandths of an inch. The complexity was staggering. Yet wartime factories had produced thousands of these engines using identical methods. Martin spent weeks learning engine assembly procedures that seemed closer to watchmaking than automotive work. The Merlin supercharger alone contained over 300 precision-machined components, each one critical to maintaining the boost pressure that gave the engine its high-altitude performance. Timing chains had to be adjusted to exact specifications. Oil pumps required careful calibration to ensure adequate lubrication under combat conditions. Every bolt, every gasket, every seal had to meet standards that exceeded anything found in civilian applications. Spring 2003 brought the first major milestone when N3200's rebuilt engine fired successfully on a test stand. The distinctive rumble of the Merlin's 12 cylinders echoed across Duxford Airfield for the first time in over 60 years. Martin stood mesmerized as the engine that had once carried Jeffrey Stevenson into combat roared back to life through the dedication of craftsmen who had refused to accept defeat. Dynamometer tests confirmed that the rebuilt power plant produced its rated 1,030 horsepower, matching original specifications exactly. Yet mechanical perfection meant nothing without airworthiness certification from the Civil Aviation Authority. Modern safety regulations demanded documentation that proved every component met contemporary standards while maintaining historical authenticity. The restoration team faced the unique challenge of satisfying bureaucrats who understood modern manufacturing but had never encountered wartime construction techniques. Every rivet, every weld, every material choice required detailed justification and supporting documentation. The certification process revealed just how thoroughly aviation had evolved since 1940. Modern aircraft use composite materials, computer-designed structures, and fail-safe systems that made catastrophic failures nearly impossible. The Spitfire represented an entirely different philosophy that accepted higher risks in exchange for maximum performance and minimum weight. Convincing regulators that this approach remained acceptable required extensive testing and analysis that consumed months of additional work. Martin found himself studying stress calculations and fatigue analysis that pushed his mechanical understanding to its limits. The mathematics governing aircraft structures were far more complex than anything he had encountered in motorcycle racing or truck maintenance. Wing loading varied continuously during flight, as fuel consumption changed the aircraft's center of gravity. Engine vibration created cyclical stresses that could cause failures after thousands of flight hours. Temperature changes expanded and contracted different materials at different rates, creating internal forces that had to be accommodated by careful design. Wind tunnel testing provided the final validation of the restoration team's work. A precise scale model of N3200 was subjected to simulated flight conditions that revealed exactly how air flowed around the rebuilt aircraft. The results matched original test data from 1940, confirming that the restoration had achieved dimensional accuracy that satisfied both historical and aerodynamic requirements. Every curve, every angle, every surface detail had been recreated with obsessive precision. As 2003 turned to 2004, the restoration entered its final phase. Systems integration required connecting hundreds of individual components into a functioning whole that could safely carry a pilot through the demanding environment of high-performance flight. Electrical systems used period-correct wiring and components that had to be sourced from specialized suppliers. Hydraulic systems operated at pressures that required careful attention to seal integrity and line routing. Even the paint scheme demanded extensive research to match colors and markings that N3200 had carried during its brief operational career. The cockpit restoration presented unique challenges that combined archaeology with engineering. Stevenson's original instrument panel had survived the crash and subsequent burial, but decades of corrosion had rendered most components inoperable. Each gauge had to be completely rebuilt, using techniques that preserved external appearance while incorporating modern reliability improvements. The process required craftsmen who understood both 1940s manufacturing methods and contemporary precision engineering. Martin spent hours in the partially completed cockpit, learning to operate systems that demanded far more pilot involvement than modern aircraft. The hand pump for raising and lowering the undercarriage required 36 deliberate strokes to complete a cycle. The propeller pitch control had only 2 positions that had to be selected manually during different phases of flight. Engine management required constant attention to temperature and pressure gauges that provided the only warning of impending mechanical failures. Flight control systems revealed the elegant simplicity that made the Spitfire so responsive to pilot inputs. Control cables ran directly from cockpit controls to movable surfaces without power assistance or artificial feel systems. The pilot's hands and feet provided direct connection to the aircraft's control surfaces, creating the telepathic responsiveness that had made the fighter so effective in combat. Yet this direct connection also meant that pilot errors could have immediate and catastrophic consequences. The restoration team's attention to authentic detail extended to components that would never be visible once the aircraft was complete. Internal structures used fasteners that matched original specifications exactly, even though modern alternatives might have provided superior strength or corrosion resistance. Wiring harnesses followed routing patterns established by Supermarines engineers, maintaining clearances and support methods that had proven successful in service. Even lubricants were sourced from suppliers who could provide formulations that matched wartime specifications. By early 2004, N3200 existed as a complete aircraft for the first time since its crash landing at Sangatte Beach. The restoration had consumed over 3 years of intensive work by some of Britain's most skilled craftsmen. Every component had been either meticulously restored or manufactured from scratch using period-correct techniques. The result was not merely a replica of a 1940 Spitfire, but an aircraft that was functionally identical to the fighter Stevenson had flown into combat over Dunkirk. Ground testing began with careful examination of every system under conditions that simulated the stresses of actual flight. Engine runs progressed from brief idle tests to full power demonstrations that confirmed the rebuilt Merlin could produce its rated output without overheating or excessive vibration. Taxi tests validated the reconstructed undercarriage and braking systems, while allowing the test pilot to become familiar with the aircraft's ground handling characteristics. Martin observed each test with the intensity of someone who had invested years of his life in the project's success. The aircraft that had once been little more than corroded fragments now sat ready for flight, its polished aluminum skin gleaming under hangar lights. The restoration had achieved something that many experts had declared impossible, transforming archaeological remains into a fully functional fighter aircraft that could safely carry a pilot through the demanding environment of aerobatic flight. Yet the ultimate test still lay ahead. No amount of ground testing could fully validate the restoration until N3200 actually took to the air and demonstrated that it could perform the mission for which it had been designed. The first flight would either vindicate years of meticulous work or reveal fatal flaws that had somehow escaped detection during the restoration process. Everything depended on 30 minutes of flight testing that would determine whether the project represented triumph or tragedy. The test pilot selected for N3200's return to flight had accumulated thousands of hours in vintage aircraft, including extensive experience with other restored Spitfires. His assessment would carry definitive weight in determining whether the restoration had successfully recreated an authentic 1940 fighter or merely produced an expensive collection of components that happened to look like an airplane. The aviation community watched with intense interest as the project approached its moment of truth. The morning of March 13, 2014, dawned clear and cold over Cambridgeshire. Inside historic Flying's hangar at Duxford, N3200 sat poised for the moment that would validate or condemn 14 years of obsessive restoration work. Guy Martin arrived before sunrise, unable to sleep through what would either be triumph or catastrophe. The aircraft that had consumed years of his life gleamed under fluorescent lights, every rivet and panel bearing witness to countless hours of meticulous craftsmanship. Yet all that work meant nothing if the fighter couldn't prove itself in the element for which it had been designed. Chief Test Pilot John Romaine completed his pre-flight inspection with the methodical precision of someone who understood that overlooked details killed pilots. He examined control surface movement, checking that cables routed correctly and response felt authentic. He tested the hand pump undercarriage system, counting each stroke required to raise and lower the gear. Most critically, he scrutinized the engine installation, verifying that the rebuilt Merlin sat properly aligned and that all connections appeared secure. The inspection consumed 90 minutes. Martin watched every moment, recognizing that Romain was evaluating not just mechanical systems, but the competence of everyone who had contributed to the restoration. The engine start sequence began at precisely 800 hours. Romain primed the fuel system, engaged the magnetos, and pressed the starter button. The Merlin's massive propeller began turning slowly, compression building as the 12 cylinders drew fuel and air into their chambers. On the fourth blade, ignition caught with a bark that echoed across the airfield. The engine settled into the distinctive rumble that had once been the soundtrack of Britain's aerial defence. Martin felt his chest vibrate with harmonic frequencies that no recording could capture. This was the sound of authentic power, unchanged since the desperate days when such engines had carried young pilots into combat over English soil. Ground crews removed wheel chocks and wing tie-downs with ceremonial precision. Decades of preparation had led to this moment when N3200 would either taxi under its own power or reveal fundamental flaws that would ground the project permanently. Romain advanced the throttle gently, feeling the aircraft surge forward as 1,030 horsepower translated into motion. The narrow undercarriage that made Spitfires notoriously difficult to handle on the ground required constant attention. Too much power would cause the tail to swing unpredictably. Too little would leave the aircraft wallowing in its own wake turbulence. The taxi test proceeded flawlessly. N3200 responded to control inputs with the crisp authority that had made the type legendary among pilots who had flown it in combat. Romain tested the brakes, finding them adequate but requiring more pedal pressure than modern aircraft. He cycled the undercarriage using the manual pump, confirming that the mechanism operated smoothly, despite its mechanical complexity. Most importantly, he assessed the engine's behaviour under varying power settings, noting that temperatures and pressures remained within acceptable limits throughout the test sequence. Martin followed the taxi trials from the hangar, binoculars trained on every detail of the aircraft's movement. The restoration team had recreated thousands of individual components, but success depended on how those components functioned as an integrated system. A single overlooked detail could cause failures that would destroy years of work in seconds. Yet N3200 moved with the purposeful grace that distinguished authentic Spitfires from replicas. The fighter seemed eager to return to its natural element, straining against the constraints of ground operations. The decision to proceed with first flight required unanimous agreement among the restoration team, test pilot, and aviation authorities. Weather conditions were perfect, with calm winds and unlimited visibility. The aircraft had passed every ground test without revealing significant problems. Most importantly, Romain expressed complete confidence in N3200's airworthiness. The Civil Aviation Authority had granted provisional flight certification based on extensive documentation of the restoration process. Everything pointed towards success, yet aviation history was littered with projects that had appeared successful until the moment of first flight. At 10:30 hours, Romain strapped himself into N3200's narrow cockpit for the flight that would either vindicate the restoration or reveal its shortcomings. The instrument panel that Martin had helped restore surrounded him with gauges and switches arranged exactly as they had been when Geoffrey Stevenson had climbed from the wreckage at Sangata Beach. The control stick felt familiar in his hands, worn smooth by countless previous pilots who had trusted their lives to identical aircraft. Everything was authentic except the pilot, and even he carried the accumulated experience of flying dozens of other Spitfires through similar test programs. The takeoff roll began with Romain holding the aircraft straight using rudder pressure and differential braking. The Merlin's torque tried to pull N3200 to the left, but experienced stick and rudder work kept the fighter tracking down the centerline. At 70 miles per hour, the elevators began generating enough lift to raise the tail, transforming the aircraft's attitude and reducing drag significantly. At 90 miles per hour, N3200 lifted smoothly into the air, climbing away from Duxford with the effortless grace that had made the type famous. Martin watched the takeoff through tears he hadn't expected. The aircraft that had been scattered fragments when he first encountered it now climbed toward clouds with the purposeful beauty that only came from perfect engineering executed flawlessly. The restoration had succeeded beyond his most optimistic expectations. N3200 wasn't merely flying, it was soaring with the confident authority of a thoroughbred fighter returned to its element. The sound of the Merlin echoed across the countryside, carrying with it the voices of pilots who had flown similar aircraft into battles that had determined the fate of nations. 20 minutes later, N3200 touched down at Duxford as gently as a leaf settling on still water. The impossible had become reality through the stubborn determination of craftsmen who refused to accept that some things were beyond saving. Guy Martin had helped transform corroded fragments into a flying legend, proving that the greatest resurrections come not through miracles, but through the patient hands of those who see potential where others see only scrap. From the beaches of Dunkirk to the workshops of Duxford, this story reminds us that with enough skill, dedication, and sheer bloody-minded persistence, even the dead can fly again.